I want to come up here to the stage to thank all our student teams for doing a fantastic job with the presentations over the last 2 days. I've been amazed by the level of science done by these researchers, and I'm sure a lot of the audience has been as well. So I would like to thank everybody for preparing the presentations fantastically well, telling us about your experience, both in terms of the science as well as the experience of taking part in the Student Spaceflight Experiments Program in general. And I think all our teams deserve one last final round of applause, so let's thank all our student presenters again. Now I'm going to be introducing Jeff Goldstein, who's going to be wrapping up the program here at the Moving Beyond Earth Gallery.
Okay, this wasn't actually planned, but as I kind of lived through these 2 days of conferencing, I needed to put some thoughts together and provide a sense of the future. Let me start off by saying that I had this remarkable honor a little over a year ago. The National Science Teachers Association asked me to give the keynote address at their national conference in San Francisco, and I was given the honor to talk to 6,000 teachers of science. And NSTA asked me to talk a little bit about what I thought science education ought to be in the 21st century. And I said a little bit yesterday about the philosophy of approach, which is that science, what practicing researchers do, grows organically from what it means to be human. That we as a species of explorers are born curious. Any parent understands that when their child is capable of expressing themselves, they start asking question after question. It's wired in us. We are born explorers. And we're also wired to be evidence-based learners, where if you poke something and you see what happens, you learn from that and you incorporate that into your world model. And so science itself, as practiced by the research community, is really just organizing that curiosity. It's organized curiosity, and it's evidence-based learning for the human race. And my firm belief has always been that science education, good science education, ought not be about memorizing lots of information. In the age of the internet, we've got Google for that. It ought to be about immersing our students in the act of journey, giving them the ability to be scientists in every sense of the word, owning the process, owning the gift of a question and trying to navigate through the universe around them in quest of an answer, and the emotional reward at the end of that journey in seeing something wholly new to them because of all of the sweat and toil that they pumped into that experience. On a larger landscape, we as a nation are in trouble. We are now being asked to compete in a 21st century global marketplace that relies heavily on science, technology, engineering, and math. And if we as a nation don't inspire and engage the next generation of scientists and engineers so that we can innovate and build things and bring them to the 21st century marketplace that requires a STEM disciplinary skill set, then we're going to be a third world nation in 50 years. It's not going to be a question about leading. It's going to be a question of just treading water. And it's going to affect the lives of every American because we are all dependent on the standard of living from which our economy wells. And so science and technology education right now is of U.S. national strategic interest. And to put this in sort of a perspective, the engineer entering the job market in just 10 years is right now in 5th grade. And so from that vantage point, STEM education has to be of U.S. national strategic interest at the elementary school level. And so this program grew from that philosophy that if you immerse students in the active journey, even at the elementary school level, and give them the ability to be scientists in every sense of the word, just stand back and be amazed. And I think that this conference proves that point very effectively. I don't think in our wildest dreams we were thinking that what we would see as the fruits of this program's labors was poised groups of young researchers that showed this level of sophistication and this level of professionalism these last 2 days. This was, in every sense of the word, a research conference. And Jim Zimbelman, who talked to you earlier, the geologist from the Center of Earth and Planetary Studies here at NASM, came in and watched the first 4 presentations, and he was blown away. And I said to Jim, I said, I told the audience yesterday, the first time I had an experience with a research conference, I was in graduate school. And I said, how about you? And he said, well, not only was I in graduate school, I already had my master's degree. So I think this program does remarkable things. And I've just got to say, I've got to echo what Harry said. You've done this amazing thing these last 2 days. So thank you so much for everything that you've done. So let me tell you a little bit about the future. This program is growing. Maybe in the next 2 or 3 years, this conference is going to be a couple of hundred presentations and a few thousand attendees. That's what we'd like to see. We work very hard at making this program better with every flight opportunity. How many of you were flying on the shuttle? Remember the MDA mini laboratory? And you've flown now on International Space Station. Do you like the fluid mixing enclosure a little bit better? So last conference, I talked to everybody about how we were moving towards a new mini lab where the volumes would be 50 to 100 times larger. Every experiment would operate independent of all the other experiments. And in that short period of time, we're now on our 3rd flight opportunity with the new mini lab. Let me also tell you that one aspect of the research experience is to report your results. And so presentations like at a conference are one venue for doing that, but the real important venue is to publish in a refereed journal. And likely many of the groups here today do not have the level of scientific depth in their research program to be able to publish in a refereed journal, though I can tell you some of the presentations I saw definitely can be peer-reviewed publications. That said, SSEP wants to provide a publication avenue online. And so we're going to, in the next couple of months, open up an entirely new web environment on the Network Hub site for publishing papers for all communities. And we're going to put out a template for what a publication might look like, which will grow naturally from the proposal guideline, where you're now adding a results and analysis and conclusions section. We also know that while the experiments, the research programs were designed by the students, it was absolutely essential for many student teams to reach out to the real research, the professional research community, to use those researchers as sounding boards, to ask questions in certain disciplinary areas, to be able to get samples that might be controlled in the post-9/11 era, and researchers have access to the vendors for those samples, to be able to expand their analysis capability by using analysis tools that may be available in local research institutions like universities. And the communities were reaching out to the researchers to serve on their Step 1 review panels. We've now got lots and lots of researchers, probably a couple of hundred, that have stepped to the plate to help this program. And I'll tell you, I've heard from so many researchers that they're quite jealous because they can't believe that you're getting this opportunity to fly in space. They never had that opportunity. But what we want to do is enlist those researchers. So we would like to create a national pool of researchers that have been involved in this program in the different science disciplines, put that online with their contact information. So if somebody in, say, Presidio, Texas, which is pretty rural, needs to talk to somebody in some science discipline, there is access to those folks on the website. So we want to build a network, a national network of researchers, and we're going to need your help to identify researchers who might want to do this. And I think one of the lessons that we learned yesterday, talking from one of the teams, is that there are alum student scientists that can serve as advisors too, because they've been through this process. And so Paul, somebody like you, could certainly be there to help guide other student researchers just coming aboard. With regard to the launch, how many Mission 2 folks do we have in the audience? And any Mission 1 reflight experiments? So I think that, you know, we're looking at a launch now. Harry, are we hearing mumblings of being pushed into early October from SpaceX? So we're not sure. We're not sure. So right now we're still targeting late September. We would love to have you down for the launch. It is an incredible experience. I can tell you, we were, I don't know if you've heard this story, but when we came down from May 19th, we had delegations from across the country. NASA invited us to the Kennedy Space Center press site. We were told that students, the last time students were in there was in the 1970s, and it was a reporter's family. Charlie Bolden, the head of NASA, and Bob Cabana, the head of Kennedy Space Center, went out of their way to come to the press site just to talk to the student researchers of SSEP. The student researchers were interviewed by media from across the country, and then we had, unfortunately, a failed launch attempt. But Gwynne Shotwell, the president of SpaceX, in the midst of walking to a press conference to talk about an aborted launch on a very important mission to SpaceX, took time to stop and talk with the SSEP students, and then later asked whether or not they could come back, and said that SpaceX would pay for all of the travel expenses to bring them back. We were VIPs of SpaceX. We went to a facility just across from the vehicle assembly building, that massive building that everybody knows at Kennedy Space Center where the vehicles are assembled. The host from SpaceX and all the dignitaries were there. All of the dignitaries from across NASA were there. And the host from SpaceX, who was a vice president, his name escapes me, before he introduced Charlie Bolden, the head of NASA, or Kennedy Space Center, or acknowledged the guests in attendance from the U.S. Air Force, he asked the SSEP students to stand and be recognized. And we were invited out on the patio, which was overlooking the vehicle assembly building. This was a night launch. The SpaceX Falcon 9 vehicle with the Dragon on top and the Mission 1 Aquarius payload aboard was off in the distance, lit by very, very bright spotlights. We were asked to go out onto the stage and face the American flag on the vehicle assembly building. And to give you a sense of how big that flag is, each stripe is wider than the lane on a highway. You could drive a bus down each stripe of that flag. And they had a trumpeter play the Star-Spangled Banner and America the Beautiful while we were watching all of this. And then we saw it launch. And we were watching a big screen inside the VIP center as this vehicle opened up a new era with the SSEP payload aboard. So if you can make it down to the launch, you got to be flexible. You never know if it's going to launch on time. It could be scrubbed. You go with Southwest so that there's no penalty for changing your ticketing. All of this information will be on the launch page. But if you can come down and join us, you will remember this for the rest of your lives. So let me go on to Mission 3. Actually, no, not Mission 3. SSEP version 2.0. One of the failings of SSEP version 1.0 is that we're not reaching enough students. I can tell you that for Mission 2, what we saw here today and yesterday were 13 proposal teams present, 13 teams. There were 779 proposals just for Mission 2. And if the average is about 5 per team, you're talking about close to 4,000 students immersed in experiment design and proposal writing. That's not enough. We should be immersing in 300,000 students in real science. And so SSEP version 2.0 is meant to do that. What we are planning now, and we hope that it will launch in the spring, is to focus on the space near-Earth environment and the radiation environment above Earth's atmosphere. We are going to fly a radiation detector on the International Space Station and keep it up permanently, serviced by the NanoRacks folks. It will probably be a Geiger-Muller tube, which is capable of detecting a range of radiation in space. If you take one of these tubes from the surface of the Earth and you go up in an airplane, you can see the counts dramatically increasing. And so the Earth's atmosphere provides an enormous amount of shielding with regard to harmful space radiation. And we're then going to allow Geiger-Muller tubes, the identical tubes, to be distributed across planet Earth so that we will have thousands of ground stations around the planet. We will then create an environment on the web where a school district can get a password and boot up an entire payload operations center in their school. So imagine a room, a technology room with 5 or 6 computers, and each computer goes to a website, and one computer becomes a mission control computer which provides the orbital trajectory of the International Space Station superimposed against the Earth, and you've got you project it with an LCD screen on the front of the room, and you've now created a mission control. You've got another monitor which provides the radiation measurements from all ground stations, including your own, superimposed across a Mercator projection of the Earth. And you have the radiation level on the International Space Station. So you can look at day-night variation. You can look at radiation changes across the surface of the Earth due to altitude. Compare that to what's up in space. And if the sun has a coronal mass ejection and it's heading towards Earth and we have a few days' notice, we'll have a global network of mission control centers that will monitor space weather coming in and see how that impacts radiation all over the planet. So one of those computer stations will be just dedicated to space weather and will hook into all of the space monitoring weather capability across the planet. And with this environment, student teams will be able to propose and design real experiments to use this global network of monitoring systems. We also are looking at flying monitors on high-altitude balloons and on NASA's fleet of aircraft. So something really big is going to be happening over the next year. And that's not to say that SSEP version 1.0 is not going to continue. We think that Mission 3 will have 25 communities aboard, and within 2 years, I think we'll be flying 100 communities with regard to the mini laboratories on station. So we're doing some really amazing things together. I hope that your communities will stay in the family, pick up on these new opportunities, new flight opportunities with the mini labs, and see me if you're interested in booting up a real payload operations center in your school district. And with that, I think we're going to conclude right now the formal program and have a wonderful time in DC. Who's staying for the fireworks? You're not going to miss it. You're going to, no matter where you are, you're going to see those fireworks. So with that, one last thank you, a very big and broad and heartfelt thank you to the National Air and Space Museum, to Michael Hulslander for making this conference possible at NASM, to Paul Griffith, who has coordinated all of the AV activities here, and your staff. And thank you so much. Go to lunch.